Let me introduce myself. I used to work at Google. I ran my startup FutureCam for a few years. FutureCam is a camera app. I worked as a CTO. I now work as a consulting CTO with multiple companies. Today, we are going to look at anti-patterns in software development. What are patterns in the first place? They are standard techniques that work well for certain situations. Think of them as a ready-made library of solutions. When you have a problem, you pull out an appropriate pattern from your library and apply it to solve your problem. You don't have to come up with the solution, it has already been built. It's like a toolbox with different tools like a screwdriver and a hammer and a wrench. You don't need to invent the tools when you have a problem. The tools are there. You just need to figure out which tool matches the problem you have. If your problem is that you need to tighten a screw, obviously you would use a screwdriver. So you just match it and pick up the appropriate tool or the appropriate pattern. So that's what patterns are, design patterns. Anti-patterns are the opposite. They're common mistakes people make. Let's look at a few of them in the FutureCam code base. The first problem is the yo-yo problem. The yo-yo problem is when you have an inheritance graph and you keep bouncing up and down the hierarchy. So here we have a mode class, which represents a mode in the app, such as a time-lapse mode or a video mode, etc. Let me just make notes as we go along so that you can refer to it. And you have different subclasses, as you can see here. Oops. Long exposure mode, light rail mode, etc. There is also an intermediate class in the hierarchy called non-real-time video mode. So this means that non-real-time video mode is a subclass of mode. And then you have time-lapse mode. So if you look at time-lapse mode, it has functions like shutter button pressed, this has functions like stop recording and shutter button pressed as well, and one calls the other. And it inherits from mode, which again has shutter button pressed and stop recording. So you can see that these functions are present at 3 layers of the hierarchy. And when you try to trace the flow of code, so let's say you're in time-lapse mode and you press the shutter button. First, you have to check whether you're recording. If so, you have to stop recording. And stop recording is in the parent class, non-real-time video mode. So you've gone to the parent class. And then the parent class calls camera changed. And camera changed is again in the subclass, time-lapse mode. So you can see how you started with the time-lapse mode, went to the parent class non-real-time video mode, then came back to the the subclass. So this is one code path. Let's look at another code path, the else part. So here time-lapse mode dot shutter button pressed calls super dot shutter button pressed, which is here. Which calls stop recording or start recording. Let's look at start recording. Okay, it has some code. and then it calls stop recording, which again, as we have seen, calls this. So you can see in multiple code paths, you are bouncing from one to the other, which makes it very hard to understand. So this is a yo-yo problem. Even now, I can't form a mental model of how this flow works. Somehow it works, and that's obviously a bad situation to be in. The other mistake here, and some of these may be mistakes, some of these may not be, these anti-patterns or code smells or design smells. You can go through this Wikipedia articles. There's one more on anti-pattern. So let's look at call super. Yeah, so what I was saying was some of these may be things we should improve in future camp, and some of these may be unavoidable. So you should use these anti-patterns or smells as a sign. If you're about to eat some food and you get a smell, you should stop and check whether it is rotten or spoiled. It doesn't mean it is. Some food, like sambar, for example, often smells in a certain way, but you eat it, it's fine. So just because there's a smell doesn't mean the food is rotten or the code is bad. It's just a sign for you to look at it more closely. So call super is the next one, where in mode, this may not be the best example. So I don't even know if there are comments, but you have some functions that say if you override this, you should call super. That's a bad design pattern, even if it doesn't document. For example, in mode, you have stop recording. Well, this is not a good example. Yeah, never mind. I'm not able to find a good example, but you have some uh, functions that if you override, you must call super. This is a bad idea because there's no way for the compiler to enforce this. And the person writing the code must also keep it in mind. Some of them should not be called the super version. It will trigger a runtime failure. Some of them may or may not be called. Some of them must be called. So it's really hard for someone to keep track of all this in their mind. So this is the call super anti pattern. The next one we'll look at is big classes. This is the worst with 1,000 lines. iOS controllers tend to become big because they serve as natural dumping grounds. In fact, as the joke goes, what does MVC stand for? Not model view controller, but massive view controller. So big classes are a problem. So this should have been refactored out. Moving on and talking about MVC, one more problem is that some of these UI classes or view classes in the MVC paradigm also have controller logic. Again, both of them should not be mixed. So you can see this is all view code, right? You're setting a frame, you're rendering a progress view. This is how it should be. See, again, you can see layout calculations. These are all fine. But when you mix them up, that is not fine. What is before and after? It's a bad name. Anyway, so moving on. The other problem is global variables. For example, if you look at AV capture device input plus util, these four camera types are global variables effectively. So now you can't control who is using them. Sometimes people argue against this guideline saying it's okay, there's only one wide angle camera. So it is by nature global. And the problem with that argument is you can't control who accesses it. So it's not a question of either one or either multiple. I mean, the same thing applies to singletons. There's only one focus rectangle. When you tap the viewfinder in a camera app, you get a focus rectangle, right? Or a focus square. There's only one location manager because the user has only one location, and so on. So whether it is singletons or it is global variables like this, the problem is everybody can access them. So any kind of layering or division of responsibilities is very easy to accidentally break. If you don't do this and you have to pass them along from one place to another, that serves as a gating check, right? You may think, hey, wait, this function or class should not be past this camera because it is unrelated to the function of the class, the responsibility of the class. But when you make them static or global, it's very easy for these things to slip. Moving on. Another anti-pattern is depending on a class rather than a protocol. So let's go back to the mode. The camera class, which is like the main class, outsources some functionality to the mode class, and it has a mode variable. So for example, when the shutter button is pressed, it tells the mode that the shutter button is pressed. And depending on the mode, it will capture it appropriately. A photo mode may take a single photo. A video mode may start recording a video. A burst mode may continue recording as long as a button is pressed. But the problem is this mode should have been a protocol or an interface for Java engineers. It's a concrete class. So now one class is depending on a concrete class. So whenever you invoke functions on the mode like this, you're thinking about the concrete implementation of the mode class. And callers should not have to think about it. They should think about the protocol, the interface, right? Like I'm informing you the shutter button is pressed. Now you do whatever you want. That should be the mental model. So that is one anti-pattern. You should think of it as a handoff. Protocols are very good at that. Moving on. Another anti-pattern or code smell is an abstraction that is split into two classes, the camera and the mode. If you ask me why some functionality is in mode and not camera, or the other way around, I can't give you a good answer. It's arbitrary. These classes should be merged. And anyhow, they talk to each other a lot. A lot of functions here call functions in mode. And a lot of things in mode go back to the camera. See, all these accessors delegate back to the camera. So these are classes with high coupling, meaning they talk to each other a lot. If you imagine each class as a box and each call from one class to another as an arrow going from one box to the other, there are a lot of arrows between the boxes, which means the boxes are effectively a single box. So this is a sign of high coupling. Classes should not be highly coupled because then one class can't work without the other. And then is it really a reusable unit of abstraction? Even if you don't plan to reuse it, that keeps its purpose clear and understandable, and people can form a mental model and work with it. So low coupling is another design smell here. Sorry, high coupling is a design smell. Coupling should be low. The other thing related to coupling is cohesion. Cohesion is, are the things in a class related to each other, or is the class serving as a dumping ground? So for example, if you look at here, a lot of this has to do with configuring the camera, like the low noise settings or the zoom level, or adding the outputs and the inputs, right? Focusing, all this is configuration. Then there's the capture part, is recording. So perhaps this class should have been split into two, configurer and capturer. So this has to do with cohesion. Cohesion asks, are the members of a class related to each other? The single responsibility principle. The camera class has two responsibilities. So the difference between cohesion and coupling, in case you're wondering, is that coupling is defined in terms of two classes. You can't ask, is this class highly coupled? The question doesn't make sense. You should ask, is this class highly coupled to another class? And if so, you have to merge them. Cohesion, on the other hand, applies to a single class. Is this class cohesive? If not, you should split it. Moving on. Bad naming. Camera doesn't represent a camera. It represents a wrapper around AV foundation, which is bad. In fact, if the phone has three cameras, a wide angle, a tele, and an ultra wide, there is only one instance of camera. So camera is not really a camera. In fact, the class that represents a camera is an AV capture device, and you will have three AV capture devices. So you can see that the camera is not a camera, and something which is not called a camera actually represents a camera. So bad naming, hard for people to understand. So if you ask me, what does this class really represent? I can't tell you. It's not even a wrapper around AV foundation because a wrapper wraps it. There are a lot of direct calls to AV foundation that don't go through the camera. Like a wrapper should contain what it's wrapping and offer a simplified interface or something. This doesn't do that. It exposes the thing that's wrapped. So any way you look at it, this class can't be justified. And this is the earliest class at FutureCamp. When I started the project, this is the first class I started with. And I mean, initially I put all the code in the main controller. That's like version 0, but version 1 was this class. And classes that are created early in the project's life have a tendency to become dumping grounds because they are perceived as central. And this is also called a God object. Like God, it knows everything, it sees everything. You shouldn't have God objects, right? It's all knowing. Now, every object needs to take care of some part of the state of the system or the functionality of the system. And also, camera is 600 lines, which again is a sign. Every class that is 600 lines is not necessarily bad, but it's a sign. You should think about, is it cohesive? Moving on. Another code smell is runtime failures like this. If shutter button is pressed, someone should override it. If not, the base class implementation gives this error. Again, this should have been made and a protocol or an interface without an implementation. And also, if you look at shutter button released, the comment says this may be useful for modes that aren't log recording to override. This is a hint to the developer of the subclass. But that is not the primary purpose of this documentation. It should be to tell you how to use it. So it should have been like this. the action will, this mode will react in a way that's appropriate to the mode, right? For example, a burst mode may stop recording when you release the finger, but a video mode may transition from stopped to recording state when you release the finger from the button. So this is the main part, right? So basically there are two different perspectives of a class and you shouldn't confuse them. There's an interface, there's the implementation, there's a subclassing. So yeah, we should avoid these runtime failures. Here is one more, user description. Oh, there's one more here. Ideally, we should have compile time failures. Moving on, is long recording. Some modes are classified as long recording modes. And if this is true, it is a long recording mode. But this is the wrong way to model it. There should have been a protocol called long recording mode. It should have been like this. Protocol mode. This is a marker interface. It doesn't have any members. It just marks that it is a long recording mode. And then the things that are long recording mode, like a time lapse mode, should inherit from long recording mode. And to check whether something is a long recording mode, currently, how do we do it? You say if it is long recording. But in the new design, the way we would do it is if mode is long recording mode, or in Java, you would use instance of. Right? This is the conventional way of doing it, not calling this function. The other code smell is action at a distance. This is where something happens in one place and something far away reacts to it. So let's look at where we post. So this is basically pub sub. You have a name. Let me just find it. Okay, never mind. I can't find it. But the point is when something happens, you post a notification. Here. So you have a bunch of notifications in your program. Each of them is an instance of some type. Now, when you want to post a notification, so for example, when the user has paid to unlock all features, we post this notification. And then someone else can listen to it and react to it. Say they can update the UI to unlock a feature that they have paid for, that the user has paid for. So now the problem is the notification is posted in one place and someone far away is reacting to it. Ideally, it shouldn't be like that. Ideally, it should be a direct connection. I should tell you. So as a metaphor, imagine me calling you on the phone versus me posting a notice in public on a notice board, let's say. And God knows who is going to look at that notice board and react to the notice posted. That's a bad design pattern. There is also a law of Demeter. So basically what that says is, you can look at the Wikipedia article later, you shouldn't have a call like this. A dot B dot C dot do something. Because this is a failure of encapsulation. A should be encapsulated. Here you're asking A for a reference to B, then you're asking B for a reference to C. I don't know if we have those here. Let me quickly try to check. Yeah, never mind. So these are some anti-patterns. Does it mean the future cam code is bad? In the sense, should we go fix all these anti-patterns? Not necessarily. As I said earlier, they are signs. They are like smelly food. But some food is naturally smelly. It's not an indication that the food is rotten. So pay attention to these smells and anti-patterns and think about whether there's a better way of doing it. If there is, try it out. If it actually cleans up your code, great. If it doesn't, that's totally fine. The goal is to have clean code. The goal is not to have patterns or to avoid anti-patterns for the heck of it. So use these as guides or indicators that you need to look into something. If you have any thoughts, leave a comment so that we can learn from each other. If you'd like to be notified when I post similar videos, assuming you found this useful, subscribe to the channel. And if you'd like me to work with your team on improving your code quality, there's a link in the description. Thank you.